what I'm going to be talking about today is it's mainly cloud machine learning, utilizing speech-to-text, ASR, right, which is automatic speech recording, and text-to-speech with FreePBX. So starting off right here, that's a mouthful, right? I kind of just went over it really quick. I'm sure, hopefully, you guys know what machine learning is, right? That kind of explains it, gives a brief overview of it. Speech-to-text and ASR are the same thing. ASR just stands for automatic speech recording. Speech-to-text is just speech-to-text, and then text-to-speech, right? And then FreePBX is a GUI for Asterisk, if you don't know, right? I want to give a brief history, or try to give a brief history of where ASR came from, where speech-to-text came from, and what I'm utilizing in this presentation for machine learning. Technically, speech-to-text and text-to-speech have also benefited from machine learning, but for the conversational methods that I use in this presentation, it's called the chatbot, which also uses machine learning, and I'll go into that in a second. So brief history, ASR, it's been worked on since the 1950s, earlier than that. There's like, in 1952, the digit recognizer, and I have some video clips of this that I can show at the end later, but basically it's guys in the 1950s talking to machines, and they would say like 1, 2, 3, and it would write it out. But the catch on that was the person who was talking was the guy who actually developed it. If anybody else did it, it wouldn't work, right? So it was also mechanical, so you'd hear it click and it switched to the different numbers, and it would do numbers 1 through 10 in a few other languages, or a few other words in English only, right? Again, that's that, and then my little image here kind of shows over the time history of ASR, right? Automatic speech recognition, and where we're at. In 1969, development of ASR kind of stopped because people realized it was a futile effort. J.R. Pierce was one of the leading guys at IBM, AT&T IBM, and he was in charge of trying to come up with ASR technology back then. And when he wrote this article, which is off to the side right here, he basically was saying we need to give up on this and pursue something else. He died around 1972. In 1976, they started up again, trying to come up with ASR technology. They got up to 1,000 words in 1976. The 1980s, they came up with a new method, the hidden Markov models. And then maybe this is when I started remembering automatic speech recognition, right? Dragon diction. I don't know if you guys ever used Dragon Dictate or Dragon Naturally Speaking. I had my grandpa used it. I actually played with it a little bit back then. It was very rudimentary. You had to talk really slowly, but you could actually write out entire Word documents based on that. And that's only in the 1997 or so, right? Let me just skip ahead here. So there's that. By the year 2000, so now we're up to right now, right? The thing with speech recognizers is when you talk into these things, the language, like sometimes words will not be recognized, sometimes words will come out wrong. This article right here, these quotes are actually from an article that was written in 1993, which was saying that even though they will learn how to use this technology, right? Because what you do is when you talk to those, when you call like my health insurance, for example, right? They have an automatic speech recognition engine. And if I talk too fast, it will error out on me. So I have to actually talk slower. So what you actually learn to do as a human is when you run into these devices, you actually talk slower. You put spaces between your words so the machine can actually understand you. So moving forward in technology with ASRs, the technology will keep getting better, but humans will also learn how to talk to machines with spaces, breaks, pauses. Right now, I can talk to you really fast, and you guys probably still understand me if I talk really fast, right? Just like that. But I have to break it up for a machine. So what happened is, it was progressing slowly. Apple released Siri in about 2010. I had a date in here, but then I removed it. And they actually bought Siri from another company. But once they bought Siri, everyone wanted to get in on that, right? Google started doing it. Microsoft launched Cortana, which if you don't know, Cortana is actually based off of a Halo character. That's where the name came from. But that's their speech agent. Amazon launched Alexa, which you can actually tap into a lot of the Amazon stuff, which I'm going to get into later when I actually try to demo some stuff. So there's cloud companies that provide speech-to-text services, Google Cloud, Microsoft Azure, Amazon Transcribe, IBM Watson speech-to-text. These are all paid services. Yes?
Dragon still does too.
Dragon still does, but do they? I don't know if they do a cloud service.
Yeah.
They do? Okay. Yeah. So all these ones, and including that, you can do that. There are also physical ones you can put on your own system, like LumenVox as an example. Anyway, so text-to-speech. So this is the opposite way around. So the first way, ASR, is me talking to a computer and it writes out the text for the computer, right? So that you can actually analyze that. The next is text-to-speech. So that would be taking a sentence and then making a computer say that sentence, right? A little brief history here. It's a little shorter than the other one. In the 1930s, Bell Labs developed the vocoder. MUSA was released. I mean, we're starting at the 1930s. So it's all like the 20th century is when all this stuff started happening. The key thing about text-to-speech is that it still remains clearly distinguishable from actual human speech. And let me just play something really quick here. I'm hoping this audio jack works. This isn't too loud. That's fine. Nope, that doesn't work. Anyways, if it did, I could actually play to you guys the little recording I have. But you guys have heard those kind of systems, right? I mean, they sound very robotic and not like human-like speech, right? I feel like as it keeps progressing, that might keep getting better. It might keep getting more fluid. But right now, it's really hard for a computer. Even when I was playing with Amazon Lex for this, getting inflections correct, right? Which is like a question mark on the end of a sentence to get like, am I asking a question, or am I asking a question without saying the question mark, right? That's hard for it to figure out as well. So some companies providing TTS that you guys could use as well. I don't know if Dragon does this as well. They do. Okay. Google Cloud, again, Microsoft Azure, IBM Watson, Amazon Poly are all services you can use, right? And I'm going to show again how to do that later. Chatbots, right? So basically what we have is we have ASR on this end, the starting end, and then the ending end we have text-to-speech, right? But you need a middle ground. You need something to be able to process that text to then send text speech back out to a user, right? It sounds weird to talk about chatbots in this form, but services like Amazon Lex, Google Assistant, or Amazon Alexa, they're all a chatbot formula, right? You give it a sentence and it tries to pull out intentions from that sentence and then formalize what you want to do with it, right? So if you guys haven't heard of Eliza, that was one of the first chatbots, right, in the 1960s. Moving forward really quick, 1972, we have Perry, then Jabberwocky, Dr. Sabitzo, yeah. And I mean, these are all still pretty generic, right? You type a sentence and they just pull out words and intentions from the sentence and then they try to formalize a response. Machine learning has really helped in this form, or in this whole area, right? Moving really quick there, you can see 2010, the revolution in chatbots came with the launch of Apple's personal assistant Siri. Again, a lot of machine learning there. Amazon introduced Alexa, right? These are services providing, companies providing services as a whole. So again, you see these big, huge players, right? Microsoft, Google, IBM, Amazon, Facebook, right? The thing with Amazon is they have a huge cloud system, right? So millions of systems. And in that, they're actually able to do a lot of machine learning. And then you benefit from their systems by paying them. I mean, like I said, it's a paid service for Amazon. I say that right here, you know. You can utilize these online cloud services to leverage your ideas for speech recognition, chatbot conversations. And what that provides you is, I talk about this a little later, I think I mentioned it, but if you guys ever use Google 411, which was like 10 years ago, It was a great little service. I used to use it all the time. But what that was is you would call in, it was voice automated, and you ask it like, what's the phone number of restaurant X by where I live, right? Free service. It would tell you that. They shut it down, I don't know, 10 years after they started it. The whole reason they ran that program was to generate machine learning models, right? They would get speech. If it couldn't figure out what you said, they would analyze it and then tell it to learn on that, and they gathered this whole thing, and then they were able to come up with, and I can't show you this here because this little thing doesn't work, the audio, I don't think doesn't work. But what it is it was Google Assistant, and I don't know if you guys have seen that at Google's I/O conference from last year. Basically what they did was they had Google Assistant call some restaurants. So what they did was somebody on this end said, Google Assistant, make me a haircut appointment, right, at random location. And then Google Assistant by itself went out and called that random haircut place, right, and made the appointment. And you hear Google Assistant like not pushed from a human, just what has like one basic thing, and it figured out how to talk to the person on the other end, which was a human, to make the appointment. And I could probably show you guys. I'll try to show you guys at the end. I might be able to turn it up to be able to show you guys. So anyways, where does Asterisk and FreePBX fit into all this, right? I'm sure you guys know Asterisk was created in 1999, FreePBX created in 2004. Back then, I got this little, I know there's a lot there, but it kind of shows what the internet was like in 2004. I mean, I don't think you could do speech to text, text to speech very well back then like you can now. Cloud services weren't a thing back then, right? Moving forward, today we have FreePBX 15 and Asterisk 16. What I use in this little demo here that I'm going to try to show you guys is the Asterisk AMI, right, which is the original, I mean, it was since Asterisk 1.0, right, connector in to talk to Asterisk. It's how you control it from the back end, right? But what else we were able to use moving forward with ASR and text-to-speech is the ARI, which allows channel access. So not that I can show you guys the audio, but I can at least show you guys the code. In the code part of it, where it connects to FreePBX, I actually take the audio from Asterisk over AMI, or ARI, and then I write it to a file, send that to Amazon, get the file back, and play it back out through ARI. And the script is actually, I don't know, less than 100 lines of how that all works, because Amazon provides SDKs as well.
That's the same way AMD works?
Same way what?
AMD.
Or AMI, you mean? Or?
No, AMD.
Oh, it's not, actually. I'll show you what, I know what you're talking about.
Goes out to Amazon as well.
Well, the AMD, the automatic machine, or answering machine detection, right?
Yeah.
That might be a different service, because I know the module in Asterisk doesn't go out to Amazon. It just checks internally, and it has internal.
The one we use
goes out.
Goes out to Amazon.
So why would you want to use FreePBX for this, right? FreePBX has an Asterisk ARI interface module, so I can just type, my Asterisk interface ARI. I can just type in the username and password right there, and it's already done. Save it, that's done. It has an AMI interface module, same thing. I can do the username and password right there. I've already done like 2 things that would take a little bit longer in Asterisk. I already have dial plan. I already have extensions. I also have a config editor module. I mean, you can go into the CLI or the SSH and do the same thing, right? But you can also just add it right there. This is how I added my 2 test apps. If you don't know, it's just Stasis is how you launch into it. So the extension I dial is 777, and then it launches the Stasis app called Wit AI, which is the ARI app name. Or Stasis Amazon Alexa, which is the ARI application name. And it's that easy. In FreePBX, you just go to config editor, you work on extensions _ custom, and then you work under the context from internal custom. But you could do this on standard FreePBX as well, right? Or standard Asterisk, even. We actually provide a package. So if you don't know, in FreePBX, there's the API, the SDK, we call it, which is bootstrapping in PHP. We also provide a version in Node.js, which you can get right now by just going to that URL or typing npm install FreePBX. And what it does is it bootstraps around FreePBX. So it gives you the MySQL connection, it gives you an AMI connection, and then what I've done there in the corner is actually connecting to ARI using the ARI client that's provided from the Digium staff.
that supported? How far back does it go?
13. 13 or higher, yep. It'd probably work in 12, I think, but 13 or higher. So you can write FreePBX application. You can write something in Node.js that utilizes FreePBX. But what it does, what I mean by that is that it just connects to the database. It gives you an AMI connection. It gives you some other developer utilities. We have a thing called KV store, which is just a key value store. It gives you access to that as well. But primarily here in FreePBX, and I can't really move over here with my, oh, I can. We set up a basic FreePBX ARI user and a basic FreePBX ARI password that's randomly generated on each install. So you can just call that back into your ARI app right here and then use it down here in the connection string, right, to connect to ARI. Okay? So why utilize cloud services? I kind of already talked about that. Whoops, let me go over here. This might be out of order. Like I said, cloud providers have massive resources. Like I said, remember Google 411. There's millions of machines in Amazon's system. There's millions of machines in Microsoft's system. There's millions of machines in Facebook systems, right? Moving back over here. If you guys don't know, TensorFlow is a machine learning language written by Google. They support it, right? So you can actually download TensorFlow on your computer and run your own machine learning, right? But you have to feed it thousands of lines of text, of data, right? That's the problem, is you need that data set that Amazon already has, right? Or that Microsoft already has. So you can do it, but if they have that data set and they're providing that data set to you for, I think it's 0.0000016th of a cent, why not use it, right? And the more people that use it, the cost goes down even lower. But the options are there to do your own thing with TensorFlow. Okay, so in creating a TTS chatbot text-to-speech example, right, what I want to do, I want to take speech from Asterisk, so somebody dials an extension or a number, or they're forwarded to like an IVR option, right? Then I want to programmatically perform commands based on speech. And then after I'm done with that, I want to output speech back to Asterisk, right? So each of these steps utilize machine learning from major cloud providers, the way that I did it, at least. The speech-to-text, because they have a huge database of speech-to-text, Google's 411, again. The chatbot experience, and then speech-to-text, right, back out. Something to consider, the way that I'm going to show how I did this with that ARI example earlier is I'm actually doing it through RESTful calls, which if you guys don't know, that means going over the internet and performing calls to like HTTP endpoints, right? So I have to call in, I'm talking to the bot, and then when I'm done, it writes the file to the system and it has to upload that file, right? So there's a delay there because I have to finish my sentence and then it has to upload it, right? With MRCP, as I'm talking, it's streaming it live, right? It's actually a SIP protocol. Version 2 uses SIP. And there's a big provider of it. It's UniMRCP, which is actually open source, and they have an Asterisk module. The stipulation to that is if you want to use like Amazon Lex or something else like Microsoft or Google, you have to pay for the plugin, right? So MRCP provides an open source Asterisk module that connects into their server, which you run on your system, which is also open source. But to actually utilize Amazon Lex or something like that, you have to pay them a fee. That's $30 a channel for Amazon Lex. But that reduces the delay that you would have normally doing these conversations. Because like I said, in the example that I'm going to show without audio, you say, like, I want to look up this. And then you have to wait because it's writing that file to the disk, and then it's uploading it. Where in this case, it wouldn't do that, right? But I don't know, $30 a channel. It's up to you if you think that's too expensive or not, but that's what's out there. The code for UniMRCP is actually online. It's buildable, like I said. I think it comes out as res_mrcp.so for Asterisk. And they tell you how to build it for Asterisk, how to build their server, and then you just download their the actual plugins are compiled like RPMs or deb packages. What I do is HTTP API connections. It's more familiar to developers, more familiar to me. So what I mean by that is, like I said, I'm taking the file and then I'm sending that file to an endpoint, right, a URL. and then I'm waiting for a response back. Okay, let me attempt to show you guys how this setup works. Get my mouse back over here, and then I will do this. Let me see if I can make this a little bit easier to see. Let's see if this is bigger. There we go. 720p, okay. So, what I've got here is this is actually how I'm connecting to Amazon Lex. Yeah, there we go. So Amazon provides this sweet little API that they call the AWS SDK. I know you guys can see my access key and my secret keys, but I really don't care because I'll just erase those and change them. And it's just a demo account anyways. So what I've got here is AWS SDK, right? Here's the FreePBX that I was talking about, right? That's if you do npm install FreePBX, which I can just do right here, npm init. This is actually the folder. And I have that, and if I do npm install FreePBX, I get the node libraries, right, from that server. And then coming over here, I can just do the same thing. I can just do npm install AWS. And I use some other libraries here. The ARI client, that's the Asterisk one, right? Again, Node.js, just npm install. And I also use this. Let me just do this really quick so they're all in the same folder place. And what I get down here is I just do freepbx.connect, then function pbx, right? And what I'm doing is, I don't know if you guys know Node or not, but it's all promise-based and everything, right? So what I get here is I actually get a config object back from these. I'm asking for the HTTP bind port, because that's where ARI works over, is asterisk HTTP server. I get the ARI user and the ARI password, and I use ARI client here, and I connect to that, right? And this is the username, and this is the password over here. And then the way that I wrote this is the class. So I actually start I start the Stasis app, which is Amazon Lex, and then I go in and I do new Amazon Lex. And again, like I said, I can't get audio to work right now. So I'm actually going to show you guys this from the Amazon Lex side. I'm going to log into the Amazon Lex console. But what I do is I answer the channel. These are all ARI commands. It's on the asterisk ARI node library on GitHub. So I answer the channel. I play a beep, right? Once I'm finished playing that beep, then I start recording the audio. And what I do, again, right, so I wait for the recording to finish. And what I do is I have a max silence of 2 seconds. So they actually say something to the bot, right? And then they have to wait 2 seconds, right? Again, MRCP solves this because it streams it directly over there. So there wouldn't be that delay, which is probably the worst part about this is that delay, right? Then I send the buffer off to Amazon Lex, which if I scroll down here, here's where I actually send. My buffer is basically just that audio file that I got from Asterisk that you can just, like I said, from ARI you can record, save it to a file, and then I send that right off to Amazon. Right? And this is like a movie lookup type application. So I just send my file off. There's my buffer, right? Post content. And then what I get back from Amazon is a response back, right? That actually tells, so what happens is there's a conversation happening. I talk, send it to Amazon. Amazon sends me a response back from Polly, right? And again, Polly is text to speech, so it actually says it back in a voice. I send that back to the Asterisk user or the client, who's ever calling, right? And the conversation continues like that as if it's a chatbot, right? That's what happens in send buffer to Lex. So since I can't get the audio here, let me attempt to get up here and just do this new window. get in here to show you guys this. And Amazon has so much stuff that it's hard to navigate around their own site sometimes. Nope. So what I've got here is these all kind of work the same online, these bots. But what would happen is we're going to pretend like over here I'm actually talking to Asterisk, since I can't show you guys that part of it without figuring out the audio issues here. What I can do is I would start off with saying, I would like to know about the matrix, right? And then it responds with, what information are you looking for? Year, plot, all. And I can do year. Whoops. And so then it gives me information back, right? So now if we imagine that Asterisk was talking, that's how it would be. I would say this in English to it, right? And it would record that and send it off. And then it would send this back as an audio string for me to be able to play in Asterisk, right? And then down here it responds, I say year, and then it responds with this, right? And surprisingly, the way that Amazon Lex and Poly works is it does not read this as 199-03-30. It reads that as March 30th, 1999 is what it says back when it reads that string, right? Because, again, machine learning, the way that Amazon Lex and Poly work together is it knows that's a date string, and it knows you as a human don't want to hear it as a bunch of numbers and then a dash and numbers and a dash, right? Just over here really quick, you can see this is how I start off my sentences, and you break them up. The little blues are intents. You guys can go in. I'm sorry, I don't want this to be an ad for Amazon. I don't work for Amazon. It was just really easy to set this up. This way, you can go into Amazon. You have to give them a credit card to be able to play with any of this stuff because they want to make sure you don't go over limits. But I mean, it's like 10,000 requests or something are free before they start charging you, right? And I'm not anywhere near that with just coming up with this. This is actually one of their examples as well. But again, it's like I would want to know about movie. I can also start off and say hi here, and it starts me all over again. And again, it's a chat box, right? So I can do this, and I can do plot, right? And the plot's all right there, right? And it will read that back, like I said. But anyways, like all of this stuff, like I said, is connected back to my simple bot here. And how many lines is it? Oh, that's nothing. So it's 172 lines of code here that I want to actually put online. I just have to ask my boss if I can do that. That basically just loops over itself, and it goes through the whole. So like I said, the bot conversational format is I talk, send off, wait for a response, right? And then I talk again, send off, wait for a response, right? And it does that in a loop. This script that I wrote actually runs in that loop. So it'll keep going until the bot conversation ends, which means Amazon sends an end request, which is, I think it's called fulfilled. Let me see here where that's at. Right there. Once it's either filled or ready for fulfillment, I just end the whole thing. Otherwise, if it's illicit intent, confirm intent, or illicit slot, I continue to send the audio back to the client and wait for a response to send back out, right? This took me about, I don't know, half a day to do. Of course, I'm a FreePBX programmer, so kind of makes it a little bit easier for me. But doing chatbots with text-to-speech and speech-to-text in Asterisk is actually fairly simple, I believe, with just ARI and just looking up SDKs of all these services online. Another one that I'll show you really quick here is the Facebook one, which is actually called Wit AI. It's completely free, which makes me kind of get hesitant because you don't, Google Voice is completely free and they shut that down, right? So let me just get my credentials out here for GitHub. Right. So I kind of did a similar thing here. The Wit AI one, like I said, is a little, it's free and it's also a little strange, and so the free part is what's worrying though. But the way that this works is I can say, I want to know about the matrix, right? So what I'm doing right now is just showing you guys I'm formulating a sentence on this chatbot engine, right? Huh? Yeah, this is Wit AI. They're owned by Facebook. It's primarily Wit AI was a separate company. Facebook bought them. Wit AI is now used primarily for chatbots on Facebook Messenger, which luckily I have not run into yet, surprisingly. I've run into real people, but that's what their primary purpose is. You can actually send speech to Wit AI. They don't have an engine to generate text-to-speech back, right? So you'd have to do that some other way. Whereas Amazon Lex, for example, or I think even Microsoft, they already generate text back to speech for you. Like if you could do the Amazon Lex model that I did my initial work off of, it actually hooks directly into Poly and it sends me an audio file back that I just sent right to Asterisk, right? But in this, with intents, what we can do here is I can say, I want, actually we're going to do, so I can do this instead. Let me do this. So if I do transfer or call Mike, right? If I do that, right, it already knows the intent is call because I've told it that. But if I do a different word for call, like, right, so if I do scream at Mike Smith, what I can do here is I highlight this, and then I'm going to do an intent, and it's going to be call. Actually, I want to do that. And then what I just did is I added that in there, right? Sorry, that's kind of going fast over how Wit AI works. But anyways, like I said here, we've got Amazon Lex to the side. And this whole system works based off of me just sending loop recordings back to Amazon Lex, and then Amazon Lex sending me a reply, and then I send responses back and forth.
Are you just binding to the events that are coming back from?
The way that it works is an ARI app's always running. So when I send the audio data to Amazon, I wait for a reply from Amazon. It's just an HTTP connection. So then they process while I wait, and then the response back, and then I send that audio back out. So there's no event there. It's just me. The event is me waiting for the user to finish recording. Yeah. Yeah. So there's no, I mean, it's async, right? So, well, what I mean by that is like, there can be multiple calls into this app, and it will be able to manage them all separately. But it will wait for a response from the user. So user has to say something, and then it will respond, right? It will process and respond. Then user has to say something, and it'll process and respond, right? So that's a quick overview of how to get FreePBX and ARI connecting together and to utilize a bot network with speech-to-text and text-to-speech, right? And that's it. I don't know if you guys have any questions. It's 11:15. I have to end right here, so. No one? Okay. Thanks, guys.